Welcome back to another digiLab Academy tutorial. I'm Anna, and today we're wrapping up our series Building Your Own AI Assistant with Streamlit, LangChain and OpenAI. Don't worry if you missed the previous videos, the links are in the description below. In this video, we're going to create a chat box, taking our application to new heights, and also we're going to further enhance the user experience. Before we dive in, make sure that you check the digiLab Academy website to check the comprehensive reading tutorial that accompanies this video. You'll also find a link to download the finished project and also additional resources. So let's jump into the last part of this series and where we put the finishing touches to our assistant. In this last part of our series, we're diving into the concept of indexes and memory in the LangChain framework. We'll be creating a chat box that can answer not only queries for documents, but also follow-up questions from the user, ensuring a seamless and interactive user experience. Indexing stands as a pivotal element with LangChain. It entails structuring documents in a manner that allows LLMs to engage with them efficiently. In this video, we will be working with document loaders, text splitters, and vector stores. A document loader in LangChain is a tool responsible for loading documents for different sources and handling various data formats, including PDFs, and converting them into a standard structure that can be processed by the LangChain system. In this video, we'll be using the class directory load, a document loader that can load multiple documents from a given directory. Text splitters are integral components responsible for breaking down larger text documents into smaller, more manageable segments. This functionality significantly enhances the efficiency of large language models in processing inputs. The choice of a text splitter depends on the specific model requirements and data nature, with considerations such as sentence or paragraph level segmentation. In this video, we'll be using a recursive character text splitter, which employs recursion as the core mechanism to accomplish text splitting. We will set it with a specific chunk size and overlap values to achieve optimal text splitting. Vector stores are specialized databases designed to store high-dimensional and embedding representations of diverse data types, including text, images, and more. These stores are used for vector search, which involves finding similar vector based on their distance in the vector space. LangChain provides tools for storing and querying similar vectors, and it offers observability features to monitor the behavior of vector stores, including tracking latency, queries, the number of documents retrieved, and the content of documents. Additionally, LangChain supports integration with various vector databases, such as Pinecone, which we will be using in this video. We will be using sentence transformer embeddings. This allows us to compute text embeddings for more than 100 languages. We can then be compared using cosine similarity to find sentences with similar meanings. The model that we will be using, all-meaning LM-L6v2, maps sentences and paragraphs to a 384-dimensional dense vector space. Conversational memory serves as the backbone for enabling chat boxes to respond coherently to multiple queries in a conversational manner. It ensures a seamless dialogue, preventing each query from being treated as an isolated input devoid of context from prior interactions. This memory feature allows a large language model to retain information about past exchanges with the user. LLMs operate in a stateless manner, processing each incoming query independently without considering the broader conversation context. When it comes to build chat boxes, the ability to remember previous interactions holds significant importance, and conversational memory facilitates this capability. Implementing conversational memory revolves around the conversation chain. Numerous types of conversational memory can be utilized with the conversation chain. One such implementation is the conversation buffer memory, which we will be using in this video. The conversation buffer memory is a straightforward method in LangChain, involving passing the raw input of past conversations between humans and AI directly to the history parameter. This approach has its pros and cons. Storing everything provides the LLM with the maximum amount of information and also is simple and intuitive, whereas the cons are that storing more tokens can lead to slower response time and higher cost, and also long conversations may face limitations as they approach the LLM token limit. In this tutorial, we will first import the essential packages and modules required for our coding environment, ensuring a robust foundation. We will use LangChains to efficiently load documents from a specific directory. These documents will then undergo a transformation, breaking into manageable chunks and evolving into embeddings. Pinecone, or vector database service, will seamlessly come into play, storing and retrieving these embeddings. We will continue enhancing the user experience using Streamlit. Two distinct tabs will be created, one dedicated to the data analysis and science, and the other hosting the Chatbox functionality. A welcome message will set the stage for an interactive and user-friendly experience. In order to make sure that our Chatbox handles queries effectively, we're going to create some auxiliary functions. We will initialize the Chat OpenAI model and set up a conversation chain to manage the Chatbox flow. Containers in Streamlit will become our canvas. Users will input queries and the Chatbox will handle responses, refined queries, and contextual matches. In this video, your AI assistant is going to level up, all set up to chat and help you with your data science problems. Let's get started. Okay, so first thing that we need to do is to set up the environment with the required libraries. In the resources, you have the requirements.txt file that contains all the packages and modules required to run the code that we're gonna go through in this video. To install all this, the only thing that you need to do is to run this in your terminal. So now that we have the environment set up, we can proceed to the next step, which is to create an index with Pinecone. The next step in order to create our Chatbox is to index the documents that our Chatbox will use to answer the queries. So the first thing that we need to do is to load the documents from our directory. And what we're going to do is to use the directory loader class provided by LangChain. So this class, what does is accepts a directory as an input and loads all the documents that are in it. For this specific project, we have created two documents. One is a text file and the other one is a PDF. The first one contains information about Elon Musk and the second one contains information about Twitter stock market. But you can customize this project by using your own documents and keep in mind that they can be various formats, so it doesn't need to be just a text file and a PDF. It can also be a CSV, JSON file, HTML, even PowerPoint if you want to. So first of all, we're going to import the directory loader, and then what we're going to do is we're going to define a function to load this document, and it's going to return the number of documents that we have loaded. So let's do that. Okay, so we're going to run this. And is printing 2 because we have loaded 2 documents. After loading these documents, we need to split these documents into smaller chunks. So what we need to do is to make sure that the size of the documents is manageable and that no important information is missed during this splitting. So in order to achieve that, we're going to use a size chunk of 500 words and a chunk overlap of 20. We are going to import recursive character text splitter from LangChain, and we're going to create a function that splits the documents in this manner. Okay, so let's run this and see what happens. Okay, so nothing happens, but if we do print length docs, and we run again, it says 8. So what it has done, it has split our documents into 8 chunks. After we have split the documents, what we need to do is transform these chunks into a format that is understandable by the LLMs. We are going to use the sentence transform embeddings, and this is where embeddings come to play. And we're going to use the model Al-Mini LM-L6B2. We're just going to import this sentence transform and embedding from LangChain and then just pass the model. Okay, so it runs correctly, and now we can move to the next step, which is create a Pinecone account. After the embeddings are created, they need to be stored in a place where they can be easily accessed and searched. Pinecone is a vector database that is perfect for this task. I have already created a Pinecone account, but it's super easy to create. We're going to create an index, so I want you to click create index, and then we're going to give it a name. For this project, I'm going to call it AI Assistant, and then the dimensions need to be, as we have mentioned at the start of the video, 384, and then we're going to use the cosine similarity metric. You can use the started plan, but if your project is a little bit more complicated, you have more data, then you might want to upgrade to the paid version. And that is it. You just need to click create index, and then you have your index created. That should appear here in indexes like this, and then you can check your API key here as well as your environment. But we have just created the index. We haven't stored the embeddings into Pinecone, and now is what we're going to do. So what we're going to do is to import Pinecone, and then from LangChain vector stores, we're going to import Pinecone. And then what we're going to do is to initialize our API key and our environment. We're going to create an index name, and then we're going to create the index. So I'm blurring my API key, and you shouldn't share this with anyone. And so that's why you can't see it, but you should replace that bit with your API key. We're gonna run this and check that it runs correctly. So remember that you can find your API key and your environment here in the API key tab in your Pinecone account. Now that the index is set up, the embeddings can be accessed and searched using the similarity search function provided by the Pinecone class. Okay, we're gonna run this. It runs fine, and then we can check if this function is working properly or not. So I'm gonna write a query that is going to be who took over Twitter, and then I'm going to pass that through the function. Right, perfect. So the information that we're requesting is in this chunk, and it's saying Twitter was founded in 2006 and was listed on the stock exchange in 2013. Since the founding of Twitter, 2022 has been an event to remember. And then as Elon Musk took over Twitter, so there is the information that has been able to access that particular information that is related to our query. Okay, so now back to our application. We're gonna enhance a little bit more the user experience. So we're gonna create two tabs. One that is gonna be devoted to the data analysis and the data science part, and the other one is gonna have the chat box. Okay, so what we're gonna do is we're gonna come here, and after the button is clicked, what we're gonna do is to say that with tab 1 and then tab 2, it's going to be equal to tabs, and then we're going to say data analysis and data science is going to be the name of our first tab, and then Chatbox is going to be the name of our second tab. So let's write it down. And then we need to encapsulate what goes to each tab. So for the first tab, it's going to encapsulate everything that we've done in the previous videos. So it's going to be with tab 1, okay? And then everything is going to be indented into that with tab 1. So let's do that. Perfect. And now at the very end of our code, we need to add with tab 2. With tab 2, and I'm gonna write a line of text so it doesn't give us an error. Okay, now so if we click let's get started, Then we can see that we have the first tab of data analysis and data science, and then the second tab, the chat box with this written text that we have added. So now what we're going to do is to add a header and also a welcoming message. Okay, we're going to run, see what happens. Perfect. So we have the title, chat box, and then welcome to the AI assistant chat box, and then a little welcoming message with some cute emojis. I have added this blank space just to give a little bit of room for what is coming next. So before we start coding our chat box, we need some auxiliary functions that are going to ensure that the chat box is working as expected. So we're going to code that before we get into the Streamlit part of coding the chat box. So I'm going to create a new script that is going to be called auxiliary functions, and we're going to code this into this script. There are a couple of things that we need to set up in this script. First, the required libraries and packages, or OpenAI API key, then the sentence transformer model. Then we need to initialize Pinecone, and then we need to load or index. So let's do all this. Again, I'm blurring both the OpenAI key and the Pinecone key. And you shouldn't share this with anyone. And in your code, make sure that you're replacing these ones with your own. Our first auxiliary function is going to be the find matches auxiliary function. And the purpose of this function is to identify the most relevant documents corresponding to a user query. So using the Pinecone vector index, the function what it's going to do is going to retrieve matches and provide the most relevant textual context in response. The second auxiliary function that we need is the query refiner. So this function serves to enhance the user's query, ensuring that it's well suited for delivering a relevant response. The model that we're going to use for this is the text DaVinci, and what it's going to do is to refine the query in alignment with the ongoing conversation log. So we're passing both the conversation and the query, and we have this prompt, which is given the following user query and conversation log, formulate a question that would be the most relevant to provide the user with an answer from the knowledge base. So then we have the conversation log and the query that is inputted by the user. The next auxiliary function that we need is going to allow us to track the conversation. So the getConversationString is going to maintain a record of the ongoing conversation. So what it's going to do is going to create a string representation of the conversation log. It's going to combine the query and the responses provided by the chat box. So now that we have our auxiliary functions, we can go to the main script and we can start building the chat box with Streamlit. First thing that we need to do is to import the required libraries. We're going to need the chat OpenAI. We're also going to need the conversation chain. And then we need to import special prompts for our chat. We also need to import the chat from Streamlit, and we also need to import our auxiliary functions. In order to make sure that the chat box works as expected, we need to use session state. And what we're going to do is to initialize two lists using this. So one list is going to be the responses and the other one is going to be the request. This list, what they're going to do is to store the history of the chatbot responses and also the user requests respectively. We discussed session state in part 1, so feel free to revisit if you need a refresher. Now what we need to do is to create an instance of Chat OpenAI, which utilizes the GPT-3.5 turbo model, the same that we've used in the previous videos, but now is with Chat OpenAI. So we need to initialize it again. Now we're going to enable our Chatbox with memory. The memory structure is going to have a size of 3, meaning that our Chatbox will remember the last 3 interactions, keeping a manageable memory size for efficiency. LangChain provides different types of message prompt templates in order to create different types of messages. For our Chatbox, we're going to use 3 of them. We're going to use the system message prompt template, the human message prompt template, and the chat prompt template. Okay, so as you can see, we have the system message template, which is saying answer the questions as truthfully as possible using the provided context. And if the answer is not contained within the text below, say, I don't know, then we have the human message prompt template and then the chat prompt template. And we have passed the history as the variable name. Now, in order to link all this together, we need to use a conversation chain. The conversation chain is essentially a workflow of how our Chatbox should operate. So it uses the user input, the prompt template formatting, and then the large language model to conduct the interactive chat. Now we're going to build the user interface. And in order to display the conversation in a user-friendly and interactive manner, we're going to use the container and text input provided by Streamlit. So now we're going to write a piece of code that is going to do the following. So when the user inputs a query, the Chatbox is going to use the predict method to generate a response. And then the response is going to be displayed in the chat interface. Okay, so we have 2 containers. We have the text container and then we have the response container. The first container, we have a text input that is the Chatbox saying, hello, how can I help you? And then we're gonna see a spinner that's gonna say thinking. Well, this is running in the background. We're gonna call the get conversation string and then the query refiner, because this is the 2 auxiliary functions that we have written before. Okay. And then what is going to happen is that the refined query is going to be displayed in the Streamlit application. Okay, so then the response is going to be predicted. It's going to pass the context and also the query. And then these are going to be appended to keep a track of both. And then we have the response container. So we're using the session state here as well. And then this is keeping track of the messages. Cool. So now the moment of truth. After we've written all these lines of code, we're gonna run our application and see what happens. Okay, so we have here our little chat box. Says, hello, how can I help you? So we're going to ask who took over Twitter, and we press enter, thinking. So the refined query is, who is the current CEO of Twitter? And the question that is going to be asked is, who is the current chief executive officer of Twitter? And then the chat box is able to give an accurate answer, which is Elon Musk took over Twitter. By the way, the theme is Twitter because in part 1 and part 2, what we did is use a CSV file that was about the stock market of Twitter. And this is the beauty of the chat box. Imagine we don't know what other companies Elon Musk owns, and that is information that we are interested in knowing. If we didn't have the memory and we ask what other companies that he owns without mentioning Elon Musk, the chat box wouldn't be able to give us an answer. But now that we have put memory into our chat box, is able to know what we're talking about, and that is one of the beauties of this. So let's do that. So it's thinking. Let's see what happens. See, so the chat box knows that we're talking about Elon Musk because it's replying. In addition to SpaceX, Tesla, Neuralink, and the Boring Company, Elon Musk has been involved in ventures such as SolarCity, OpenAI, and Sim2. And there you have it. We have reached the end of our series. You've transformed your AI assistant in a powerful ally, ready to tackle the complexity of your projects. But the magic doesn't end here. Remember that you can customize your AI assistant to your own data, goals, and needs. Try loading different types of documents, use your own databases, and play with other models and parameters. Remember to download a completed project and resources from the digiLab Academy website. There, you'll also discover additional resources and courses on data science and AI. The written tutorial is also linked in the description. If you like this video, don't forget to like and subscribe and to share with your friends. Let me know in the comments what would you like to see for our next video. Thank you so much for joining me in this journey. I'm looking forward to seeing you in our next adventure. Until then, happy coding and goodbye.